All right, I guess we're in business, folks. So this is the solution video for March 18th. Looks like I'm live and ready to go. Yeah, so as we discussed in class, I'm going to go over a few of the finance problems. And then considering time, I'm not going to do a whole solution to the projects, but I will sort of make some comments. I'm not very far in grading them. You watch your email. I'll be emailing out a PDF with comments on it for your feedback on that. Yeah, so let's jump right in. Let's talk about a simple one. Number one from the finance packet. Number one from the finance packet. So this is a lump sum problem. If you look back at it, we're the problem is we're investing a lump sum of $55,000. We're doing it for 10 years and we're compounding monthly. So our ingredients look something like this: N is 12, T is 10, P0 or P naught is $55,000. And we have a annual interest rate, our APR, of 0.03 or 3%. All right, and we just set up our formula. So we have P0, 1 plus R over N to the N times T. And we'll just plug in the pieces. P is $55,000. And 1 plus 0.03 over 12 to the 12 times 10. And if we plug that into our calculator into Desmos, we should get something like 74,214.45 or 44. I'm not sure how rounding works with money. I doubt the bank would give you that cent. Okay. So that's pretty straightforward. Just wanted to get it out there. I had some questions about it on Thursday, so I thought I would go ahead and just give it a nice clean go. Okay, number 9. So in number 9, we're comparing the two solutions. So I posted a video related to this that features the unbreakable Kimmy Schmidt. But essentially what we have here is someone has won the lottery. They can either get 100,000 now or $11,000 per year for 10 years. And the question is, what's better? Should I take the lump sum or should I take, and I guess we should point out here that at the end of 10 years, they will have paid you $110,000. So on the face of it, it looks like taking the annuity would be a better deal. This is an annuity, yeah. But it doesn't turn out to be the case. So let's break it up into cases and see, because you could invest this lump sum as soon as you get it, right? So let's see what it's like. How much money do you have investing $11,000 as an annuity for 10 years, or just taking the lump sum for 10 years and investing that for 10 years? So let's see here. So case 1, we have N is 1. That's nice and easy. R is 0.09, and you'll get that from the problem statement. T is 10 years, and P0 is our $100,000. All right, so if we set up our formula again, P is going to be 100,000, 1 plus 0.09 divided by 1, and then 1 times 10. And if we do that to that, we get 236,736.37. Okay, so option 2. Take the annuity instead. Still n equals 1. Still r equals 0.09. But now we have the r instead of the p0, and that's going to be dollars 11,000. Not 10, but 11,000. All right. And t is still 10 as well. And so we plug that into the a is r 1 plus r little r over n to the n times t minus a 1. And that's all over little r over n. So if we compute that, 11,000 1 plus 0.09 to the 1 times 10 minus 1. Divide all that by 0.09 divided by 1, better known as 0.09. And in the end, you only get 167,122.23 out of that. So yes, take the lump sum should you win the lottery. I don't tend to advocate playing the lottery, but suppose you won, that's how you handle so excuse me, it doesn't matter like if they tax you a ton, right? You know, they could tax you a ridiculous amount and we'd still have quite a bit more money. Okay, moving on. So that was number 9. I'm going to do 10, 12, and 13 next, and then I'll make a few comments on the projects, and we'll call it a day. Alrighty, so number 10. This is the one where you have to kind of flip over the formula. So it asks not what's my amount after so many years, but instead, what do my payments have to be? So the question here is not amount after t years, but what payments give a certain amount. After, in this case, after 4 years. Okay, so you can dive straight into the problem, but I would suggest taking a step back and just examining the formula for a moment. So we have the formula A, R, 1 plus R over N to the N times T minus 1. All of that over R divided by N. Okay, so I can move this over there, multiply both sides by R over N, and then I can divide both sides by this fella here, because this is over 1, right? So I can always just multiply both sides by the denominator, divide both sides by the numerator. The multiplication by R, since R is multiplied by all of this, that's why we're able to do this. So we perform those two little bits of algebra, and we get that R is equivalent to little r divided by n times a divided by 1 plus r divided by little r divided by little n times t minus a 1. Okay. And so if we pop in our pieces for that, so for this problem, we had an R of 0.06. You can just get this from the problem statement. We had an N as 12, so we're compounding monthly here. What else do we need? We have a final amount we need, because we're buying a car. We need a final amount of $16,000. So 10 and 11 are very similar problems. If you want to take a look at this solution and then see if, and check your work, see if you can do 11 after this. Okay. We have an A, we have an R, we have an N, we have a T is 4 years, and we're ready to rock. Okay, so R is going to be 0.06 divided by 12 times our 16,000, that'll be dollars, We're going to divide all that by 1 plus r 0.06 over 12. We're going to put that to the 12 times 4 power. So 12 for number of compoundings, 4 for years. Subtract a 1 from that. And if we plug that into Desmos or pop it into our calculator, we arrive at 12,141.36. Now, after doing that last problem, you might think, well, that doesn't seem like a lot of money. But keep in mind that if we had just thrown this into a savings account, say, I'm sorry, guys, I moved on. I'm looking at the wrong part of my notes. That is entirely incorrect there. That computation comes out to be 295.76. Sorry, got ahead of myself there. And that's the answer for number 10. I'm about to do number 12, which my comments from a few minutes ago actually apply to. So let's just move right along to number 12. 12. Okay, so in this case, we're gonna do annuity for 8 years, followed by lump for 6. And so this is the sort of mathematical meaning or the financial meaning of what the problem statement is talking about. Is we invest $250 quarterly into an account. So that tells you that since we're making a payment, this is going to be an annuity kind of thing. Then we don't touch the account, right? I think the problem specifically says don't touch it, leave it there, or something like that. So in that case, we're back to using the output of our annuity as the input for our lump. And yeah, so we'll just go through it. So it's a two-part. So part 1, we're going to annuity 8 years. All right, so put our pieces together. R is $250. T is going to be 8 years this time. We're compounding quarterly, so that's 4 times a year. And we've got a nice big interest rate this time, 0.102, 10%, right? Or 10.2%. Okay, so at the end of 8 years, we'll have 250, 1 plus 0.0102 over 4, 4 times 8 minus 1, 0.102 over 4. Yep. All right, and at the end of 8 years, we have 12,000. Whoops. Here's where the 12,000 that was erroneously in the last problem comes back. 12,141.36. Now we should ask ourselves, well, that doesn't seem like a lot, but if we just made payments, quarterly payments of 250 for 8 years, we have 250 times 8 times 4 payments a year. That would only be $8,000. So you really are doing yourself a favor by saving in these kind of annuity situations. Okay, so then for the next part, we have P, our P0. We're going to take this for our P0. So that's going to be 12,141.36. And yeah, we just throw it straight into the formula. 1 plus 0.102, so that percent rate is a decimal again, divided by 4 compoundings a year, then to the 4 compoundings a year times 8 years. And the output of that will be 27,177.44. And there we go with that. So let's see. How long have I been talking at you guys? Oh, it won't tell me. Well, that's awful nice of it. Okay. No worries then. Let's do 13. So 13, this is our loan payment. So I think we're going to do a few more finance problems this week, but in general, now you've seen all the different kinds of finance problems we'll do, including, so the ordinary annuity, both finding the payments and finding the final amount, the lump sum, both finding the initial investment and the final amount. And now we're going to do loans. All right, so this is loan payment. So we have the Kaufmans have a down payment. I always want to ask what the down payment is. And that's going to be $20,000. The house costs, house cost is $260,000. And let's see, with this down payment, of course, they'll be making monthly payments. You almost assume that with these mortgages. Or they're going to have a 7.8 interest rate, so 0.078. It's a 30-year mortgage, so you get your T equals 30 from that. And your P0, that's going to be the cost minus the down payment. And so we have $240,000 there. All right, let's do it too. Their monthly payments is going to be equal to 0.078. So the formula, maybe I'll state the formula, then I'll use it. So the formula is our monthly payments. So this is monthly payments. That is equal to R over N times P0. This is our cost minus the down payment. We're going to divide all of that by 1 minus 1 plus R over N to the minus NT. And I've emphasized this a couple times, but just to be clear, that minus sign matters. Yeah. Okay. So plug in our pieces. 0.078 over N is 12. There's our $240,000. Divide all that by 1 minus 1 plus 0.078 over 12 to the minus 12 times 30 power. And if we calculate all that, I get 1,727.69 per month. That's your monthly payments. So the first time I did this problem, I felt like I had finally discovered why every suburban gentleman has high blood pressure. Sure, an American diet has a lot of sodium and red meat, but this right here, all those suburban fathers with the high blood pressure, they got to come up with that every month. And not just that, because in the back of their head, let's think, we made 12 payments a year for 30 years, and those payments were $1,727.69. You paid $621,968.11 for that house that only cost $260. So we should be kind to people that have a mortgage payment. They've got a lot on their minds, I guess, is the conclusion there. Okay, so just a couple quick comments about the projects. So let's talk about sea level rise first. So that doesn't have anything to do with sea level rise. Sea level rise. So you guys looking at some of the projects, you're correct. It's a surprising amount. So the times we're looking for are 233 and 661, I believe. So this is to get to the seawall. And this is 2 years. Yeah. This is to top the seawall. So some cautions. So these are the numbers you get. If you're getting 2000 or something like that, some decimal error happened. I'm not sure what it is. I've been looking for it, but a couple things to look at is we have a long beach. It's the hypotenuse of the beach that is 52 feet. And here we have our angle of elevation, right? And up here, there's our angle of depression, which is also 3 degrees. Okay. And we can kind of think about that as beaches are pretty shallow slope, right? So if we were looking, if this angle was 3 degrees instead, right? So this is a good picture, but we'll just say here, if it was the other way, and this is kind of how you can convince yourself that you've drawn the picture right. If it was the other way, if this was the 3 degree angle right here, then you'd have a picture that looked like this. And beaches don't tend to be nearly vertical. So quick way to check your work there. Okay, but we'll just move right along. So keep that in mind. So in this case, you have sine of 3 degrees is equal to, I'll call this y over 52 feet. And keep in mind that here's the 5-foot seawall, right? 5 more feet. 5 more feet up there. So yeah, keep that in mind. So you get something like 2.27 for the first one, and then 7.27 for the second one. I think I'll leave it there. I think that's enough. Oh yeah, and remember, so this is either in feet, right? Y is in feet, and your rate is inches per year, right? So you got to convert one way or the other. Either convert this rate to feet or this feet to inches. One way or the other, it's got to happen. Okay, yeah, I'll leave it there. So the runoff project. First of all, get your area straight from Google Maps. Then once you have that, you could do area times depth, and that gets you a volume. Then, that volume will be cubic feet, cubic inches. So convert it to something. Swimming pools, beer cans, whatever seems to make sense. Whimsy is encouraged. So make sure to compare to some other units. And yeah, so area depth, make sure to compare to some other unit. I think that's about all I have to say about this one. I will show you guys real quick how how to do this. Go over here. Is that what you guys are seeing? Can't see what you guys are seeing. Let me try this one more time. Application window. All right, looks like I'm in business. Okay, so I don't know. Let's find a building more interesting than that. Here's a building. I don't know what this is, but it's building. So I'm on a Mac, so I'm going to do Control click. This is just a right click if you're on a PC. I'm going to hit this measure distance button, and so it gives me a dot. The trick is move this dot to the edge first. Now we're just going to play connect the dots. So I'm going to click to add a new leg to my journey. But if I keep clicking around till I've drawn all the way around my shape, and I kind of, once the shape looks closed to Google Maps, right, and I'll just drag this so it's exactly, so I've gone all the way around this building. Now I have a total distance, a total area down here. So I have the total distance traveled, but I also have a total area. This is the number I'd like you guys to use because, and then I would like to include an image of this in your write-up. So yeah, that's about all I have to say to you guys about the projects and the homeworks. Let's see, if you watch this before tomorrow, we will be having a quiz on Monday instead of Thursday. And it will be mostly finance. I think there's a slight amount of linear equations review on it. And after that, we'll start Tuesday on exponential functions. We'll find out why Jacob Bernoulli was such a smartass. Well, anyway, I hope you guys have a good Sunday, and I'll see you tomorrow.